Hello students, today's lesson is on multiplying rational expressions. Last week you all learned how to simplify rational expressions. Now multiplying rational expressions is like simplifying all these rational expressions together. You can actually extend this line, so it's like a simplifying and combining rational expressions. So we will come to that as we do our examples, but first let's talk about a couple of vocabulary words. Rational. Okay, let's recall what rational numbers were. So a rational number is any number that can be written in the form a divided by b, where a is an integer and b is an integer and b is not equal to 0. Because what happens when b is equal to 0? Anything divided by 0 becomes undefined, so we do not want that. So that is a restriction on a rational number. The examples would be, say, negative 3 by 2 and say 2 is equal to 0 is not acceptable. Coming to the word expressions, when in addition to numbers there are variables, like in this case there are numbers and variables here. This is a monomial, it could be a polynomial. So expressions have numbers and variables and signs like addition, subtraction, all put together. So those are expressions. But at the same time, if it is a rational expression, the restrictions are the same. The denominator at any cost should not be equal to 0. So we have to put restrictions on everything that is making the denominator 0. So if y is equal to 0, we are seeing that the denominator becomes 0. Here, if x is equal to 0, the denominator becomes equal to 0. So let's put those restrictions that in this rational expression, y cannot be equal to 0 and x cannot be equal to 0, because these two will make the rational expression undefined. Okay, so let's now talk about the steps for multiplication. First step is look at every numerator and every denominator. In both there are two rational expressions here, so look at all of them and see that if you can write it as a product of factors. So let's talk about the numbers first. There's a number 45 up here in the numerator and 75 in the denominator. Last week in the videos you saw how to simplify the ratio of numbers. You can use your calculator, find the greatest common denominator, or you can use a multiplication chart. This is added to your resources on Hub. So, and look for the column under which you will find 45 and 75 together. So I can see that under column 15 here, 45 here, and then there is a 75. And then see the corresponding rows. This is row 3, that means 3 times 15 makes a 45. And this is row 5, so 5 times 15 makes a 75. So I'm going to write my 45 as 3 times 15. 3 times 15, and 75 as 5 times 15. Okay, let's talk about the variables now. So let's first copy them down. I have an x cube in the numerator, a y in the numerator, and then there is a y square in the denominator here, and there is an x in the denominator. I'm going to simplify this using the exponent rules. A quick recall of the exponent rules. When the bases are same, the exponents are multiplied and the powers get added. That's a product rule. Quotient rule is the powers get subtracted if the exponents are divided with the same base. And then there is a negative exponent rule, that if the power is negative, you make it positive by writing the reciprocal of the exponent. So applying them here now, x cube, I have an x cube and there is no other x in the numerator, I have an x in the denominator. So applying the quotient rule, x cube minus x3 minus 1. And then y has a power 1 in the numerator, y to the power 1 and then minus 2. So now I can cancel out the common factor here, the numerator with the denominator. And I can simplify this 45 by 75 becomes a 3 by 5. X to the power 3 minus 1 is 2, and y 1 minus 2, y to the power 1 minus 2 becomes y to the power negative 1. So now using the negative exponent rule, I'm going to write down my final answer, which is 3 by 5 x to the power 2 and y to the power negative 1 comes in the denominator as y to the power 1, which is y. So this is my simplified form of the product of these two rational expressions. And but my answer is not complete without the restrictions, so I'm going to always include the restrictions with my answer, because otherwise my rational expression, the answer will be undefined. Okay, let's move on to another example, and we also quickly go over the steps and tools for multiplying rational expressions here. So look at this. I have a rational expression. The numerator is a quadratic trinomial. Okay, I will be factoring it by the x method. The denominator here is a linear binomial. Then in the next expression, I have a monomial here, doesn't need factoring, already has two factors, 5 and x squared. And the denominator here is a cubic binomial, and I can see the variable here and a variable here ready to be some GCF ready to be factored out. So I'm going to take that up one by one. Let's go over the steps. Step 1. Write the numerator and the denominator of every rational expression as a product of factors. Whatever you can write as a product of factors, or wherever you can take the GCF out and write it as a product of the GCF and the other factor. So you do that to every numerator and every denominator. Step 2. So you write those as a product of factors, and then you write the restrictions or what values of variables in the denominator are making the denominator 0. So, or the expression undefined. Okay. Once you state out the restriction, the last step would be cancel out the common factors. If there is a common factor in the numerator and denominator, cancel that out. And after that, if more simplification is required, in some of the questions you'll see that more simplification is required, then you do that. So let's take it up. I'll just create some room. Now that we are aware of the steps, we will just keep coming back to them. So let's create some room here and let's start factoring. So I've copied down the numerator of the first expression, the denominator, numerator of the second one, and the denominator of the second one. So I'm going to factor them out one by one. So the first one, you're going to use because it's a quadratic trinomial, you can use the x method. So I'm going to draw my x here. So here your a is equal to 1, which is a coefficient of x squared, b is the coefficient of x, which is negative 1, and then c is the number. So I'm going to write the AC here. AC, a times c is negative 6, and then b is negative 1. Now I'm looking for two numbers which when multiplied will give me negative 6 and when added will give me 1. So you're going to make a factor tree using the AC, which is 6. Ignore the sign. So you are familiar with this method. So you just start making your factors 1, 6, 2, 3. Now you have to keep this in mind that the product is negative. That means one of the two numbers has to be negative. And the sum is also negative. That means the bigger number is negative. So let's try this. The bigger number negative, so if we put negative 3 here and 2 here, they multiply up to negative 6 and they add up to negative 1. So I found my two numbers. So I'm going to split up the middle one into this is equal to x square minus 3x plus 2x minus 6 minus 6. Make the pairs and take the greatest common factor out. So there's a variable here, take the variable with the lower power out. There's no number here to be factored out, so I'm going to take the x out, and I need to make an x square, so another x times x makes an x square, and then I need to make a negative 3x, so just multiply this with negative 3. Repeat this factor, minus 3, and copy down the middle number in front of x, which is a positive 2, right? So now just make sure 2 times x is 2x and 2 times negative 3 is negative 6. So I'm going to write down the two factors, x plus 2 and x minus 3. Okay, so that is how I have factored out x squared minus x minus 6. So I'm just going to create some room here. I will write down the factors here of x squared minus x minus 6, which I just found out were x plus 2 and x minus 3. Okay, so let's just create a little more room so we can complete the question in this part. And then we go to factor out all other remaining numerators and denominators. Okay, this should be good. Okay, so now this denominator. So we see that 2 goes into 6. There is no variable here, so no variable can be factored out. So 2, if you factor it out, you need to make a 2x, so 2 times x, and you need to make a negative 6, so 2 times negative 3. So this is how you have factored out. So this is done, this is done. Let's go to the next one. It's a monomial. 5x squared already is factored out, so you don't need to do that. Now let's go to the last one. This has a coefficient 1, so no number needs to be factored out or can be factored out. So let's talk about the variable. This term has a variable, this all. If all the terms have the same variable, you take the smallest power of that variable out, which is here it's x squared, this is x cubed. So I take the x square out, and I need to make an x cube here. So multiply with another x, 2 x's and 1 x make 3 x's. And then I need to make a 2x squared. I have x squared already there. All I have to do is multiply by 2. Okay, so now I have written all the numerators and denominators in terms of the product of their factors. So let's start the work now. So replace them with the product of factors. So this one, x plus 2 times x minus 3 divided by 2x minus 6 became 2 times x minus 3 multiplied by 5x squared. We didn't do anything to it, 5x squared. And then you have the denominator of the second rational expression. We factored it as a product of x squared and x plus 2. So what is your step 2 now? Step 2 is you have to state the restrictions. What is making the denominator? What values of x? Because that is the only variable present here. What values of x are making the denominator equal to 0? So you see here, you can put x minus 3 equal to 0 and solve for x. So it becomes x equals 3, right? So x is equal to 3 is making the denominator 0. Similarly, x is equal to 0 is making the denominator 0. Similarly, when you put x plus 2 equals 0 and solve for x, you will see that x equals negative 2. You can see that negative 2 plus 2 makes the denominator 0. So what are our restrictions now? Our restrictions are, x is not equal to 3, x is not equal to 0, and x is not equal to negative 2. Okay, so now I'm going to cancel out all the common factors. X plus 2 gets cancelled with x plus 2. X minus 3 gets cancelled out with x minus 3. And x squared gets cancelled out with x squared. And my final answer becomes, I have only 5 left in the numerator and only 2 left in the denominator. So my answer is 5